अच्छा चले गाइस आसिफ आवाज आ रही है। ये हम ना कर रहे थे रेट ऑफ रिएक्शन। वी डिड डिस्कस a lot of things in the last lecture, ठीक है, तो उधर से हम आगे कंटिन्यू करें. So now what we're going to do is we're going to try and figure out the factors that will affect the rate of reaction, ठीक है. तो factors that are going to affect rate of reaction, ठीक है. तो there are a number of factors which are going to affect the rate of reaction. लेकिन all of them they depend on a couple of things, ठीक है. वो couple of things की हैं कि it depends on collisions. कि हर reaction में ना what happens is कि you've got uh, इसको एक second. अच्छा, हर reaction what you have is you've got particles, ठीक है. And these particles, ठीक है, तो ये मेरे पास दो particles हो गए, ठीक है. यहाँ पे let's say इसको copy करके let's have two more particles, ठीक है. अच्छा, so चलिए सही है. अच्छा, so let's say these are my four particles and there are फोर अदर पार्टिकल्स. वो यहाँ पे मैं ड्रॉ कर लेता हूँ. ये फोर और पार्टिकल्स आ गए, ठीक है. इनका कलर चेंज कर सकते हैं. चेंज स्टाइल, बस डन, ठीक है. अच्छा, सो देयर फोर डिफरेंट पार्टिकल्स. पार्टिकल्स ए, रिएक्टेंट ए, और यहाँ पे देयर इज रिएक्टेंट नंबर, रिएक्टेंट बी. एंड दीज पार्टिकल्स आर गोइंग टू रिएक्ट. एंड व्हेन दे आर गोइंग टू रिएक्ट इट ऑल डिपेंड्स ऑन द कोलिजन्स दैट आर गोइंग टू हैपन, ठीक है. कोलाइड करेंगे, देयर इज गोइंग टू बी अ कोलिजन, ठीक है, between the particles. So the rate of the reaction or the reaction itself depends on collisions. Collisions hongi, then the reaction is going to happen. Old bonds are going to be broken. Okay, when they collide, old bonds are going to be broken, and new bonds are going to be formed, and the reaction is going to take place. Okay, so it all depends on collisions. Now, when you describe the rate of reaction, it all depends on collisions, and collisions are going to be described in two ways. ठीक है, दो तरीके होंगे. One way is that you talk about the frequency of collisions. Like how many times do they collide, right? अगर वो ज़्यादा collide करें, so you're obviously going to have a faster reaction. The second way that they're going to be described is the effectiveness of collisions. Or the better way of writing that is proportional of effective collisions. Of effective, or we can write successful collisions. What that means is that but they are colliding, but are they colliding effectively? Are they colliding with enough force that leads to the breakage of old bonds and the formation of new bonds? But if they're colliding with each other very very slowly, okay, these particles, the particles of A are moving, but they are moving very very slowly, and they collide and bump. Nothing happens. But if they collide with a lot of force, then the collisions are going to be very effective, and there's higher chances of reactions happening. So it's not all about collisions, frequency of collisions. Maybe you have millions of collisions happening per second, but nothing happens. Why? Because the collisions are just not effective. That is what happens at low temperatures. So, so every collision, every factor is going to be discussed in these two terms, and the two terms are, one is the frequency. You're going to talk about the frequency, and the other term is you're going to talk about the effectiveness of those collisions. So moving on, I'm going to talk about the factors now. The number one factor that affects the rate of reaction of any reaction, that is, okay, that's temperature, right? That's number one. You want to increase the speed of reaction, you increase temperature, it always works. So at higher temperature, you have a faster reaction. Whenever you have a higher temperature, you are going to get a faster reaction, right? So you're going to get a faster reaction. So the issue is, and the explanation for that, why do you get a faster reaction? So at a higher temperature, particles, they're going to ask you, it's going to be a 3-4 mark question, 2-3 mark question. So you're going to write that particles have more kinetic energy. Remember, your wording has to be it has to be written in exactly the same way. Particles have, as if they have more kinetic energy, and so they travel faster. ठीक है? Or simply you can just write that they have more kinetic energy. I can put that in brackets, so they travel faster. Hence, the frequency of collisions and the proportion of effective collisions, they both increase. So the frequency of collisions, because they're traveling faster, they're going to bump into each other with a, a, a higher number of times, right? And the proportion of effective collisions, they're going to collide with a lot more force. So the collisions are going to be more effective, right? So and the proportion of effective collisions, they both increase. ठीक है, they both increase. ठीक है, higher temperature, you get a faster reaction, right? Uh, so the explanation, you have to get the explanation right. ठीक है, so the frequency and the amount of effective collisions, they both increase. ठीक है, that's temperature. The second one, the second one is about pressure. So what happens when you increase pressure? So the first thing that happens is uh, draw I have to draw a container. Now, you get rid of this. And let's say the container has a piston. It's got a movable piston. ठीक है. And so let's say this. So it's got a movable piston, and you've got this as well. एक second, let me just draw this. ठीक. Okay, so we've got a container with a piston, and it's got tiny particles in it, which are randomly moving around. ठीक है, so they're all randomly moving around. Remember, this factor is only for gases, because gases are the only things that are compressible. So when you take something to a higher pressure, what you're actually doing is you're compressing it. So higher pressure means I'm compressing it. So when you increase pressure, well, first thing is I'm going to write the summary. You get a faster reaction, right? So you are going to get a faster reaction. But why? ठीक है, what's the answer for that? So when you increase pressure, the volume decreases. ठीक है, higher pressure, volume decreases because in physics you've studied that pressure is inversely proportional to volume, right? So the volume decreases. So the volume is decreasing. So particles are now closer to each other. And if they're closer together, they're going to bump into each other with a lot more frequently. ठीक है, if the space around it decreases, you compress it, the particles would bump into each other a lot more. So the frequency of collisions would increase. So there will be more frequent collisions. Increases, ठीक है. So the frequency of collision increases, and उससे क्या होगा? The proportion of effective collisions, they remain exactly the same. So I'm going to write that in brackets. That's not needed because that's not a factor in this case. Proportion of effective, so they're not gaining energy, so they're not bumping into each other with a lot more force. तो वो अभी तक उसी तरह collide कर रहे हैं. So the proportion of effective collisions, it remains the same. ठीक है, तो ये हो गया हमारा प्रेशर का. ठीक है, so increase pressure. Remember, when you increase pressure, only the frequency of collisions would increase. ठीक है, सिर्फ ये. और दूसरे factors, they are not going to take up, the effectiveness would not be a factor. ठीक है. अच्छा, अब तीसरे पे आ जाओ कि तीसरा क्या है. तीसरा है third one. अच्छा, let's talk about concentration. So now this concentration thing is only mainly applicable to solutions or gases, but normally for gases we deal with pressure. We don't talk about concentration, but normally the term concentration applies to solution. So let's say I have a container, so here's my container, and that container has a solution in it. तो ये इसके अंदर solution पड़ा हुआ है, and let's say there's a salt solution. So there's this solution, and then there's another solution which is more concentrated. So the more concentrated the solution is, it's going to have it's going to have more particles. ठीक है, उसके अंदर ना ये particles जो होंगे वो ज़्यादा होंगे. They'll be closer to each other, and it's going to be a lot more concentrated. जो dilute होगा, that's going to be, the particles would be like far away from each other. ठीक है, तो ऐसे ये particle मेरे से उठा ही नहीं जा रहा. इसको उठा के इधर करें, पूरा ही उठ के. एक सेकंड. तो ठीक है. अच्छा, one of them is dilute, the other one is concentrated. अब I guess मुझे बताने की जरूरत नहीं है कि it's pretty obvious which one is dilute, which one is concentrated, लेकिन फिर भी मैं लिख देता हूँ कि this one is the one that's more concentrated. ठीक है. So it's pretty obvious कि if you have higher concentration, you get faster reaction, right? So if you have higher concentration, so you do have faster reaction. लेकिन क्यों? So it's kind of the same explanation, faster rate. Why? Because particles are closer to each other, or particles are closer together, and therefore you get more frequent collisions. So the frequency of collisions increases. ठीक है. और इसमें भी याद रखना, the proportion of effective collisions that kind of remains exactly the same. ठीक है. तो सिर्फ और सिर्फ the frequency of collisions would increase. ठीक है. अच्छा, अब हमने concentration कर लिया कि your higher concentration would definitely increase the rate of reaction, right? Next वाले पे चलते हैं. Fourth क्या होगा? Fourth would be, what's fourth? Fourth is surface area. अच्छा, what does surface area do? The surface area is whether you've got small particles or big lumps. So remember, जो छोटे particles, small particles like powdered, ठीक है? So if you have particles that are crushed and powdered like this, so let's say small lumps, and then you have large pieces, right? And let's say ये जो है ना, this is powdered, right? So remember, powdered has more surface area. This one has more surface area, and this one has less surface area. Achha, so the thing with powdered is the thing with powdered is so the thing with powdered is if you have more smaller lumps, you're going to have more surface area. So you're going to have more frequent collisions. अगर ये होगा ना, this you're going to have more frequent collisions because a lot of those particles would be able to react. When you have large lumps, so the particles that are trapped inside, they will not be able to react. The outer surface particles would be able to react, but not the inner. But when you break them into small, tiny pieces, then all of them will be able to react. So they're going to have a larger surface area. So in this case, you're going to have more frequent collisions and hence a faster rate of reaction. So the rate of reaction would be faster in this case. Okay, so keep that in mind. Powdered, the reaction would be a lot faster. Okay, number five. Okay, number five is a catalyst. What happens when you add a catalyst? First thing is we need to know what does the catalyst do. So first thing is catalyst. It lowers the activation energy. What is the activation energy? It is the energy that is needed at the start of the reaction, or it's the minimum energy needed to start a reaction. Uh, why do reactions need energy at the start? To break old bonds. So almost all reactions they require some energy at the start. Why? Because you have to break old bonds. For example, if H2 and Cl2 molecules are reacting, they're going to bump into each other. And the thing is that energy would be needed at the start, so you could break old bonds. They're going to smash together, and once they smash and they collide and they bump, it has to be done with enough force so that all the atoms they split up, the molecule breaks, and all the old bonds are broken, right? And then new bonds would be formed. Then H and Cl could get together and form HCl. The other H and Cl could get together and they could form HCl as well. So normally what happens is, that you need some energy at the start of the reaction so that you could break old bonds. Because if those are not broken, and let me take this as one single. This was one molecule. This was one single Cl2 molecule, right? So you got to break all bonds. So which is why there's some energy that's needed right at the start of the reaction, right? So another property of catalysts is they remain unchanged during a reaction. So another property of catalysts is catalysts remain unchanged after a reaction. So what you're going to write is that, so this is how you're going to phrase your answer. What does the catalyst do? It speeds up the reaction, right? So how does it do that? It speeds up the reaction by lowering the activation energy, EA, which is activation energy. Hence, you have more, hence, proportion of effective collisions increases. So in this case, so hence the proportion of effective collisions, it increases. You still have the same, hence only the proportion of effective collisions increases. The collisions are more effective. Frequency of collisions remains exactly the same. That does not change. So you still have 100 collisions happening, except the only thing is that they are now being more effective. A catalyst kind of makes it easier for you to break bonds, so that it's so the reactions are a lot more successful. The collisions are a lot more successful. So in the case of catalyst, keep this in mind that it's the effectiveness of the collisions that will increase the effectiveness of collisions, right? Now, so keep this in mind. Surface area, you get more frequent collisions. Concentration, you get more frequent collisions. ठीक है, उसमें भी frequency. Pressure, you get more frequent collisions. With temperature, you get more frequent as well as effective collisions. ठीक है, both of them increase. So remember, this is how you're going to describe the factors that affect the rate of reaction: temperature, pressure. Remember, the wordings have to be exactly the same. The phrases, the scientific terminology that's going to be used, that should always be exactly the same. Surface area and catalyst. ठीक है? So I guess that's about it. Rate of reaction. So we next class we'll do क्या करेंगे? We'll do past paper questions. ठीक है? Related to rate of reaction.